All right, Declan, we did the time test already, and it was the one that had, hey, Brody, what are the first two problems on that time test?
3 times 3 and 2 times, no, 2 times 3.
Okay, so the first two problems were 3 times 3 and 2 times 3. I'll let you time yourself. Just make sure you get them all done. Tomorrow, we're going to do a mixture of 2s and 3s. Okay, and we'll do that for a while. So it's going to be both. So yes, you'll still need to know how to go 3, 6, 9, 12, 15, 18, but sometimes you'll need to go 2, 4, 6, 8, 10, 12, count by 2s. Hopefully on the 2s though, you guys are more thinking doubles because it's the repeated addition, right? Which actually, that's what I wanted to actually talk about. Somebody remind me, so far, what have we talked about for what is multiplication? When we say multiplication, what are we really saying is going on? What is multiplication? Olivia?
Repeated addition.
There you go. One thing we have to know is that it is repeated addition. Now, I'm going to do that one second. So I'll put it up there, but I'm going to put the other one first. And then we'll go back to that. What else is it?
It's counting.
It is skip counting, which is kind of the repeated addition part of it. And I'll explain that in just a minute. But it's something else. Liam?
It's like a group of numbers that's packed into 2 things.
Okay. If I gave you these two letters,
Equator?
oh, not quite.
Equator.
It has to do with what multiplication is, because we have groups. What?
So there's one group
Mm-hmm.
of how many groups is one, showing how much, like 6 groups of 5.
There you go. Every group has to have 5, though, right?
Mm-hmm.
Okay, so what word am I thinking of here? If everyone has to be... not quite.
Equal.
Equal.
Groups.
Equal groups. Okay, so when we think of multiplication, somebody give me 2 one-digit numbers that we could multiply. You don't even have to know the answer to this, but they can only be one-digit numbers. Don't say 59 times 87. One-digit numbers. Don't do 9 times 9 either. Is that what you were thinking? Did you think of something different? Lily, what do you got?
8 times 8.
8 times 8. Who says, I have 0 idea what 8 times 8 is? Who says I already know? What is it?
I think it's 64.
I think you're right. Did you just have it memorized?
Yeah, I remember the one.
Okay. Here's the thing with multiplication. Eventually, you want to have all of these things memorized. Because you don't want to draw equal groups or everything, do you? Do you want to write out a plus, an adding thing? I don't think so. Okay? So you eventually want to just have them memorized. That when you see 8 times 8, 64. There's actually a little rhyme that goes with that. Do you know the rhyme?
No, I was just going to say a thought about it. If there's like something that is, like an odd number is going to be an odd answer, and
Well, for certain numbers, for like 2s.
Yeah, like 2, like equal numbers.
Well, let me see. 2s are always 2, 4, 6, 8. 3s are 3, 6, 9, 12. That goes back and forth.
Odd numbers are going to be an odd answer, and the 2 kind of answers are going to be what is it called?
An even.
Even answer.
Well, 2s are always going to be evens. But an odd number multiplied isn't always an odd. It depends on the other number. Okay, let's get back to the topic at hand. 8 times 8. I remember this one because there's a little thing that you can say to yourself. 8 and 8 went through the door, and when they left, they were 64. Honestly, that when I was doing multiplication when I was little, that one helped me remember that 8 times 8 was 64, because it was one I had trouble remembering. Okay? If we don't know what that is, then we can say, well, it's equal groups. So I would have to go 1, 2, 3, 4, 5, 6, 7. There's my 8 groups. How many are in every single group? How many are in each group?
8.
There's 8 in every group. 1, 2, 3, 4, 5, 6, 7, 8. Thanks, Lily, for picking a big number.
I wanted to pick 9.
Wow.
Wait, what is it?
My hand is getting tired. I'm making all these X's. Some of them are turning into plus signs. They're supposed to be X's.
I think we should use dots.
I probably should have. It would have been faster. But now I'm done. Oh, I did. That would not be equal group. Okay, now here's the thing. I have 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. Every single group has 8 in the group. If I count all the X's, that's going to be the answer to 8 times 8. Yeah. I don't really want to count all those. I could probably count by 2s though, couldn't I? Go like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 58, 60, 62. Oh, I missed one, 64. And I get my 64. This is something that helps us know that's what multiplication is. I could actually use this to find an answer, but I think we all agree this is the longest way to find the answer, isn't it? Because you have to make the picture and then you have to count all of them. And you have to make sure you count accurately. Because if I forget to count one of these, I'm not going to be right. Okay? So that's what multiplication really is. It's equal groups. Could I do this? Look what I'm going to make. I'm going to make new groups. Based on this, could I make a multiplication problem out of that?
No.
Could I make a multiplication problem out of that?
No.
Oh, yes.
I've got a group of 2, a group of 3, a group of 2, and a group of 3.
No, wait, no.
Can somebody explain to me why I can or I can't? I might be pointing at something that's a hint. Why can I or can't I make a multiplication problem out of a group of 2, a group of 3, a group of 3, and a group of 2? Brody, why? First of all, yes or no?
No.
Okay, why?
Because it's equal groups and those groups are not equal.
Yeah, this and this are not equal groups, are they? If I do not have equal groups, I cannot make a multiplication problem out of it. This would have to be just an addition problem. 2 plus 3 plus 3 plus 2. That's what I would have to do to figure it out. Okay? Yes?
Also, aren't you, like, in times, can't you only have, like, 2 factors? But then you would have...
You technically can have 3 factors. So, like, to get really fancy, and this is what William's probably going to tell me, so I'm not going to say it, and I'll let him say it first.
Actually, it was actually more for that 8 times 8 problem.
Okay.
That's the way of counting by 16 because there's 8 in each group. In each 2, and 8 plus 8 is 16.
Right.
So you can count each 2 groups.
Okay, so you could do kind of a quicker addition problem like this. Like that? Okay. And for some people, they'd say, yeah, that helps. Some people would go, ugh. 4 6s added together? Ugh.
It's basically 12 plus 12.
It is, you're right, because 6 and 6 is 12. 6 and 6 is 12. That's, okay, by the way, this is the kind of stuff I want your brain to start doing. that when it sees a math problem, it doesn't go, ugh. It goes, well, what can I do that I know how to do that'll make this easy for me? Okay? And that's why we talk about that math toolbox all the time, right? About how we want to be able to figure things out without having to worry too much about our brain going, I don't know what to do. Right? We want our brains to be able to go, I don't know the answer yet, but I know that I could probably figure it out. Okay? I'm going to show you something on this one, though. I can't make one multiplication problem from this, but I could do this. Two times 2 plus 2 times 3. Because I have two groups of 2 groups with 2 in every group, and I have 2 groups of 3, 2 groups with 3 in every group. And if I figured those out, I can just add them together. Okay? It's just a way of doing it. Now, we're not doing this today, so I'm going to get rid of that. So you don't get confused. All right? But just to remind us, this is really what multiplication is. But you have to have equal groups to do it. That's why it's also just repeated addition. What would this problem look like as an addition problem? 8 times 8. And you don't have to say all of them. You can just tell me how many of them I need. Jordan, what would it be?
Plus 8 plus 8 plus 8.
How many times am I going to write the number 8?
8
I'm going to write it 8 times, right? 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay, I got them all. That is basically the same as this, just in number form, isn't it? Okay? Because if I put a little plus sign between all these guys, that's really all that we're doing. We're adding all of our groups together. Okay? Who says, yeah, if we can memorize our multiplication facts, that's going to make life easier. Just knowing that 8 and 8 is 64, I don't have to count all these. I don't have to do 8 plus 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 8. And I don't even know if I said all the 8. Okay? Today, though, we're going to learn one more new way to think about multiplication. And the new word is going to be something that's going to go in your math dictionary. So grab your math dictionaries and get those out. And can you unmute the board?
We need our math book.
All right. Find the word array in your math dictionary. It should be easy because it starts with an A, so it's the first one in that 4th chapter. All right. And I'm going to really quickly go see what they put for the definition of array back here. Okay, so what I'm going to have you write is, and I'll actually just make it really big, but you're going to write what's in red there, which I will have to make a new box because I'm going to make it bigger so you can see it easier. Okay, so write down this as your definition for an array. I'll give you a minute or two to do that. Work carefully, but don't skip any of the words. There's a lot of words, so you have to kind of be careful. It's a glutastrophe. Oh, man. Oh, you know what, though? You don't have anything. Oh, is that your last word? We'll just write something. For now, we'll do the front for array. so get that written in. Objects or symbols displayed in rows of the same length and columns of the same length. Oh, really? For what? You just are? All right, get that written in. I'll be back in just a second. Who's still writing that in? Okay, double check that you get everything in there. Objects and symbols displayed in rows of the same length and columns of the same length. If you're done writing that, then what I want you to do is make an actual array, because this is what an array looks like. Now, this doesn't have to be perfect when you make it. But do you see there's 3 down the side and 4 across the top? That would equal 3 times 4. It doesn't have to be a box though. I could also do this. I could just do objects. And that would be the same thing. 3 times 4. 3 down the side, 4 across the top. So go ahead and make a picture of an array like that on yours too. Still writing those. Okay, go ahead and keep going. Be done like within the next minute. Declan, remember you can always fast forward if you're done writing to the next thing that we do. All right, is anybody still working now? Okay. and a 4 on top. Okay? Alright, on our page, that's a little too difficult. Okay, on our page at the top, let's start to learn a little bit more about arrays. Can somebody read what an array is at the top there? Only Bethany knows how to read it. Zoe, go ahead and read it nice and loud.
An array has rows of equal length and columns of equal length.
Okay, let's make sure that we understand the word row and the word column. When we think of a row, I want you to think about going to like a movie. Because when I go to a movie, let's pretend that that's the actual screen, and I'm going to come into the movie theater, and this is the aisle in the middle. As I'm going down, here's a row, here's a row of seats, this is the next row of seats, and then there's a front row of seats. So when you think of the word row, think of what's going side to side. Okay? When you think of the word column, think of a building. Because some buildings have columns in the front that help hold it up. Okay? If you go to the Capitol, that building in Springfield, that has big giant columns. They go up and down. So think of a column in a building goes up and down. So just remember, rows in a movie theater, side to side. Columns, like on a building, go up and down. Yes, Brody?
So, where are we supposed to write row equals?
Nowhere. Write it in your brain. Okay? Just remember that a row is like in a movie theater, and a column is like on a building. Okay? Zoe?
My dad, his building kind of has columns.
Okay. Yeah, a lot of buildings do.
Downtown.
Yeah, because they kind of, just the people that make the building think they look nice like that. So it makes them an entry area. Okay? All right. So that's what rows and columns are. So when we look at this again, the rows have to be equal length. It's kind of like saying equal groups, isn't it? And the columns are going to be equal length. Also, kind of like having equal groups. Okay? All right. On this one, it says, make an array on a piece of paper, arrange the tiles in 4 rows with 3 tiles in each row. Okay. If I need 4 rows, is that like making 4 lines up and down or 4 lines across? Which one is that? 4 rows. Is that going to be up and down or across? What's that going to be, Colton?
It's going to be across.
Okay, it's going to be 4 rows that are going to go across. So what I'm going to do right now, okay, now remember, you're missing math class when you do that, right? Okay, so go ahead. Is I'm going to do this. Since I need 4 rows, there's a row, there's a row, there's a row. Go ahead and write this on your paper, in your book on the side there. These are going to be my rows. I don't have how many things in each row yet, but that's what this next thing is going to be. 4 rows with 3 in each row. So that means if this is the first row, I have 1, and I have to count that one. 1, 2, 3. Here's my next row. I got to put 3 there. 1, 2, 3. Here's my next row. 1, 2, 3. And here's my 4th row. 1, 2, 3. Did you see what I was doing okay, Olivia? Okay. We're on page 305. All right. That's it right there. Whoop. You were just on it. Whoop. Nope. Right there. Okay? All right, so this array has 4 rows and how many columns? How many columns does it have? Bethany?
3.
It's got 3 columns. 1 column, 2 columns, 3 columns. Now, here's the deal. An array helps us with multiplication because really, couldn't I think of this as like equal groups? How can I split this into equal groups? Somebody give me a hand here. How many groups do I have? And how many are in each group? What do you think, Liam?
There's 3 in each group.
Okay, so I can think of it like this. 1 group, 2 groups, 3 groups, 4 groups. If I think of it that way, that's 4 groups with 3 in each group. 4 times 3. So these 4 times these 3. Okay? How else could I do it though? I could do it a different way. How could I do it?
Just going down.
Okay, I could say, here's a group, and this time I'll do an actual instead of a dotted line. Here's a group. Here's a group. Here's a group. How many groups do I have?
3.
3 groups. How many are in each group, Courtney?
4.
4 are in each group. This is going to get into another word we're going to be working on, which you're going to go, oh, well, that totally makes sense. You know what it's going to be?
Yeah, it's going to be the switch around one.
It is the switch around one. It's like the addition, right?
Yeah.
Yeah, that. Who remembers the name of that property in addition, where it says 4 plus 6 is the same as 6 plus 4? They should just call it the switch around one, shouldn't they?
Yeah.
That'd be easier to remember. What is it though?
I think it starts with a C.
You're correct. Calling somebody to help you out with the rest of the word.
Avery.
I just had it.
Ah! Calling somebody that's not Avery. Yeah, the commutative property. So we're going to get to that in just a minute. But hopefully you guys realize that. You went, hey, we did that with addition. It works with multiplication too. It's the commutative property, but this time it'll be of multiplication. Okay? We'll get to that on the next page. But let's look at this. Count. What's the total number of tiles? Well, if we count these tiles, how many are there? How many tiles are there if we actually counted them? Did you count them? Bethany?
3, 6, 9, 12.
Okay. Did you see what she did? She said, well, there's 3 here, 3, 3, and 3. They're equal groups. So she just counted by 3. She skip counted, which is the same as adding 3s, isn't it? 3, 6, 9, 12. So there's going to be 12 in our group. Okay? All right. If you take your book, and we kind of already did this by showing the other groups, but anytime you have an array, if you tilt your array, that's going to help us see the commutative property. Let's just turn the page. Since we've been talking about this so much, let's just flip the page, and in your dictionary, find commutative property. Yes.
Do you have to do the grouping and stuff?
You don't have to. All right. Nope. All right. Yep. Chapter 4, commutative property of multiplication, it should say. Find that in your dictionary. Then I'm going to have you write down. I'm going to do it this cheaty way to make it easy on me. Because I think everything should be easy on me. This is not easy for you though. Look at all the words they're using. All right, write down this red part here. Remember that while you're writing things in, if you can kind of remember a couple words in a row, especially if they're shorter words, like that, the, if you can remember it's that, the, and just do those without looking back up, that'll help you go a little bit quicker. But remember, make sure you're writing the accurate words. The property that states that the order in which two numbers are multiplied does not change the product. They should have said the order in which two factors are multiplied, shouldn't they? Use that math word, factors, instead of just numbers. But we'll leave it as numbers. Yep.
Is it this one?
Commutative property, yep. You should be writing. Nothing else until you work it. And it really is the same as the one for addition, isn't it? It's just now it's multiplying and it's product instead of the sum. If you really want to, if you want to use the word factors instead of numbers, feel free, because it's multiplying, so those would be called factors, wouldn't they? Oh, you just enough space, huh? We're not going to write anything else because it already has a good example up on your thing, doesn't it? Where it says 3 times 6 equals 6 times 3. Flip those numbers, it stays the same.
Could we? If we want to?
You want to do another one? Yes. 12 hours. We're doing a new thing where everybody just stays here. Like, you don't have to go home anymore. Alright, this should be written in though. Make sure you're focusing on that. Sorry I'm talking. I'm being distracted. Sorry, Olivia. I'm distracting you. Were you distracted? No. Okay. Alright, tell you what, we've been doing a lot of writing, a lot of just kind of working and thinking. Before we continue talking about arrays, we're going to do a go noodle. So if you're still writing, get that done as quickly as you can. And the only people left are William, 10 is Jordan, 8 is Declan, who's not here, 7 is 7, Olivia, and 5, which is Campbell. Oh, and 11, which is Bethany. Or you already did it. Well, I already did it. So, speaking of, did anybody try the read your mind thing?
I did.
Did it work?
Yes.
No.
No.
Who says yes, it worked when I did it? Who says it did not work when I did it? Who says I didn't do it? Okay. All right. Who's 7? 7 is Avery. No, Olivia. Okay. Is anybody still writing? Okay, get done in the next minute. And you can start coming over, Olivia, or do you want to just do it from there? Okay. Thanks. Oh, she's on the
Okay, I'm done. Do you have to write any numbers or anything?
No, you
Is that Zoe? I did not. Declan is still watching this, and he can do a go noodle with us. Or he can fast forward through it. All right.
Don't fast forward through
Here
it.
we go. Can you remember the rest of it, William?
Yeah.
Does not. Or you like it does. Oh, okay. So we're in product. Okay. Come on. Oh, she's not doing it over here. Do you have a channel that you already have in mind? Stop me if you see something. I'll go back up.
YouTube.
Hey, you're not Olivia. Do you not like making decisions, Olivia? Not really? How about if I choose Moose Tube and then you pick the one we do? Because usually those are pretty good. Alright. We got Coast to Coast, Que de Hista, sounds in Spanish. Healthy Tip, Marshmallow Dash, Noodle Hand Giant, Bear Breath, Mariquette Milk, is that Little Green Froggy, Great Big Moose, No Noodler Went Yodeling, Nicky Nacky Nacky Noo. Triangle, well, we can't really do the triangle dance because we'd have to grab onto each other and beat each other's faces. Boom Chicka Boom, Yes I Want to Build a Snowman, Clean Up, Baby Shark, Sweet Georgia Brown. See any yet? The meatball one? Alright.
Oh, yeah.
Fabio's Meatball Run.
To bring her some juicy meatballs.
This one makes me tired.
Grandma, you love your meatballs. It's just like me. Let's go. We gotta run so the meatballs don't get cold. Double open my mouth.
Stopping running. Okay, close.
Almost there.
All right.
Almost there, Chuck.
Okay, so we put down, let's make that smaller. Okay, so we have what the commutative property is. And arrays help us kind of see the commutative property a little bit easier when we work with them. Yes? Oh, go ahead. When he gets back. All right. So if we look at this, it says use tiles to make an array. We're just going to draw the tiles. 5 rows with 2 tiles. 5 rows of 2 tiles. See if you can do that on your own. Raise your hand if you want a hint. Okay? Since I'm doing 5 rows, those will be my rows. 1, 2, 3, 4, 5 rows. And I need 2 in each row. So 5 rows of 2 tiles. Yeah, we'll go ahead. Alright. I'm hoping that whatever you made eventually kind of look like that.
Yep.
That's 5 rows. There's 2 tiles in every single row. What would the addition sentence look like for that? If we're doing the rows first and then the tiles, so it's like 5 groups of 2. Brody, what would it be?
5 plus 5 plus 5 plus 5 plus 5.
Okay, that would be 5, 10, 15, 20. That'd be 25. Are there 25 tiles?
No.
Hey, Brody. Are there 25 tiles here?
1, 2, 3. No.
Okay, what's 5 plus 5 plus 5 plus 5? We'll cut by 5s.
5, 10, 15, 20, 25. 2s.
Oh, what am I going to do?
2s.
So 2 plus,
2 plus 5.
well,
Or 2 times 5.
well, that'll be the multiplication problem, but what's the addition problem?
2 plus 2.
There we go.
2 plus 2.
Now, that is a very, 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 very common mistake to make when we move to arrays. Is people just pick a number. I see a number. I'm going to add it together a bunch of times. Who would say I've been guilty of doing that? Like on a word problem. I just randomly picked 2 numbers and I did something with them and then wrote an answer. Okay, you got to read what you're supposed to do. In this case, 5 rows of 2 is 2 plus 2 plus 2 plus 2 plus 2. It's like 5 groups of 2, isn't it? Okay? What would the multiplication problem be? The rows and the number in each row. So what would that be? What would the multiplication look like for this? What would that be?
And then would be 2 rows with 5.
Well, are there 2 rows? If you're going to the theater, you're trying to find your row. How many rows are there? How many?
5.
Yeah, there's going to be 5 rows. How many are in each row then? Calvin? 2 in each row. And hopefully we know that that's going to be 10, because that was 10, and we could have counted those and seen that there were 10. I'm going to be kind of specific. Remember when I said that when we do this as groups, and how many in each group, I want it in that order. When we do it as an array, I always want you to put the number of rows first, and then the number in each row as the second number. Okay? All right. Jump over to page 207. All right. Do you have a different pencil that's maybe? Because after about 20 seconds, if you can't get a pencil sharpened, I would give up on it. Okay. On this page, this is going to be similar to your assignment. So we're going to go through this really quick so I can give you some assignment time. It should be fairly simple if you just kind of take it easy and think about it. Draw an array to find the product. Remember, I said I want the first number to be the number of rows. If you want to, you can do that. So 4 times 2, I have to draw an array for 4 times 2. So I need 4 rows with 2 in each row. Now, you can do it however you want. If you want to do it as just things, there's my 4 rows. And now I'm going to go 1, 2, 1, 2, 1, 2, and make 2 in each one. Or you could do this. You could kind of make a box and go like this. 1, 2. See how that's also 4 rows? And I have 2 in each row. Who likes doing the box version? Who likes doing the objects version? Okay. Does it really make a difference?
No.
Not really. It's whichever one you're better at doing. Some people are better at doing this because sometimes when they try to do the box, they end up like going like that, and then they're like crazy different sizes, right? Whereas this, you don't have to worry about the size of your box. Okay? So what would 4 times 2 equal? What would that be? Calvin? 8. Do your own. 3 times 5. Remember, 3 is the rows. Draw an array that shows 3 rows with 5 in each row. 3 rows with 5 in each row. Draw the array. 3 rows, 5 in each row. Remember, rows go across. Three rows with 5 in each row. Some people also do this. They go like 1, 2, 3, because my rows are going to be going across eventually, and I need 3 of them, right? So you can start by just doing that. And if I need 5 in every row, I can go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And hopefully yours looks like that. Did anybody accidentally do it this way?
Yes.
Okay, that technically would be 5 times 3. That's 5 rows with the 3 in each row. Somebody tell me what property says it really doesn't make a big difference other than Mr. Springer's making a big difference out of it. What property says that?
Yeah.
Oh, what property is it? That was part of the question. Yes? Yeah, the commutative says these two things are exactly the same. It's just that this is that if you knock it over. Right? The 3 goes down to the side, doesn't it? Okay? So, if though it has you draw an array, keep that in mind. The first number is going to be the rows. So I need 3 rows of 5. All right? Okay, look down at number 6. It says write an addition sentence and a multiplication sentence to show equal rows. On this one, I personally like to do the multiplication sentence first, because it helps me. How many rows are there in this picture? How many rows are there? How many you got? 4. 1, 2, 3, 4 rows times how many in each row? How many are in each row? Colton, how many?
5.
There's 5. 1, 2, 3, 4, 5 in each row. So 4 times 5. So now I'm going to go up and do my addition. What would my addition be? Make sure you're thinking of the right numbers. 4 groups of 5. So what am I actually adding, Lily?
The 5?
Yes, I'm doing 5 plus 5 plus 5 plus 5. Somebody tell me what's the answer for both of those? 20. Veinte in Spanish. All right? So that's how that kind of a problem would work. Okay? Here's one nice thing about arrays. Sometimes you can use arrays to help you. Like, if I was making muffins, and I look at my muffin pan, that's what my muffin pan looks like. Now, I can count how many muffins I'm going to have. I'll end up with 8 muffins. Or I can go, well, it's 4 times 2. That's 8. Here's how another way some people do this. Sometimes if you go into a theater, you know how they have this number of rows and the exact same number of chairs in every row? If I went to a theater and there were 15 rows and there were 12 seats in each row, I can turn that into a multiplication problem and I can figure out how many seats there are. Because I'll take my 15 rows and multiply it times the 12 seats in every row. Now, we can't do that yet, okay? But that would be easier than going like this. 1, 2, 3, 4, 5, 6, 7, and just counting all the rows, wouldn't it? Once you know how to do this, that makes it easier. And that is another nice thing about arrays, all right? Okay, your assignment is going to be, let me get the assignment going first. Pages, oops, nope, there it is. Page, let me make this smaller, it's too big. 209 and 210. 209 and 210. If you look at those pages, 209, you're going to draw the array to find the product. So on 1 and 2, you need to actually draw the array. If you go to the back side, it's like the other one. It says write an addition sentence and a multiplication sentence to show equal group, so to show equal rows. That's why they give you 2 lines for each one. Then, down here it says draw 2 arrays to model 2 times 3 equals 6. Think about the commutative property and how their arrays will look a little different. And then you just have a couple of word problems. Okay? You have a little bit of time. You got about 5 minutes to start now. Ask if you need help, and I will come around and help you out. Do you want to go kind of sit over and work me a little bit afterwards? That's okay, good work on it. Just work on that. If you want me to check that your rows and your columns are correct, I can do that too. You're just not sure what you're doing right away. 5 rows. So right now you've got 3, so we need to add how many more rows? We're on top, we're on the bottom, right? not really that concerned about how perfect your arrays look as long as they're facing the right direction. Yes? Ooh, but we need to do an array. You did groups. Okay? Do you think you know how to do the array?
I do.
Okay. Yep.
Why do 6 this way and 5 that way?
Correct. Okay, let's come up with this again. You have percentages in this one. So you've got 1, 2, 3, 4, 5. And we need 7 this one, right? 1, 2, 3, 4, 5. That needs to go out. 2 more, doesn't it? Mm-hmm.
Okay, how would you do it?
1, 2, 3, 4, 5. And then this should have how many? 1, 2, 3, 4, 5. Only 2 more. Sorry, Declan. I kept this going. You could get your assignment going too.